What is a map? Well, a map is a data structure. This is not specific to Java, but computer science in general. It is associated with a key with exactly one value. When we're talking about data structure, a map stores unordered values by mapping each value to a specific key. Let's say if your key is a string by its animal name, in this case could be bat, could be fox. So this is one way of mapping a key to a specific animal. But what you can't do is mapping a key to two different values. There is a unique value associated with each key. That's one property of this map. And the other property is the item that is inserted inside this data structure of key values. They are unordered. Data structure doesn't really take extra care in ordering the keys. As soon as you insert it, it could be anywhere. So this expedites insertion and also retrieval of keys. Once you get the key, you can get the value too. A map structure does not permit duplicate keys. If there's going to be duplicate keys, we're going to run into what's called collision, and that is pretty expensive proposition, just appending these keys and storing them into maybe a linked list or something. And because you're towing along also the value associated with the key, having more duplicate keys means more iterations you have to go through, assuming everything is in collisions. And that's the worst case scenario. Two distinct keys can map onto the same value. So what does that mean? It's possible for Doc and Rabbit to map to the same values as long as there's no key collision. In this case, Doc and Rabbit, these are two different keys. The enforcement of a uniqueness is on the key, meaning the key is a set. A set is a collection of items that do not duplicate. Let's move on to our very next slide here. A couple of examples here illustrating legal mapping variations. You can have number mapping into these names. These could be enums, constant in Java, or they can just be a string. You can have string to string, string to zero. You can have string to numbers or another object. So it's possible to have key being any Java class and your value being another Java class, object to object. And inside these objects, let's say if this value right here is a composite of sorts. So once you wrap this information inside an object, this object could be using different ways of describing certain things. They all have their attributes associated with it. And this becomes a complicated object that you can associate with to a key, a unique key. So this is a quick illustration of what a map is conceptually. This is a author's implementation of map interface. It describes functional abstractions of what a map does. If you have a map, you have a couple of operations that you want to associate with it. One is insertion of elements. The second one is retrieval of an element. The third one is removal of an element. These are the three important functions that you want to associate with a map. This is the same as in Java. Insertion is what we call put. Retrieval is what we call get. And the removal is what we call remove. Put requires that you insert both key value. There are Java generic data type, K and V. So K signifies key values value. This could be integer, it could be string or string integer. It doesn't really matter how you define it. This allows you to input key value into your underlying buffer, building out the entire map data structure. Let's say if K already exists, then the value associated with the entry is replaced at value V. The original value is returned. For getting the value out of it, if the K already exists, then you get what you want. Otherwise, null is returned. Removal. Removing a key, if the key exists, then the entry is removed. And the value associated with that entry is returned. So this value is actually associated with the key that's being removed. Otherwise, null is returned. So these are the three important aspects of it. You will see a couple of the other observer is empty, is null, size, contain. Contains, check to see if this key K exists or not. Depends on what your underlying buffer is. If the underlying buffer is an array and the key is the array indexing, then it's O of one. But if this is a linked list, you can't do array search, indexing zero, or random access. In that case, you have to loop through every single one of these elements inside the linked list, and that is O of n, right? So it depends on what your underlying data structure is for storing these informations, your contain and isempty. They all have different operational efficiency associated with it. Next up, we're going to talk about how you iterate information inside a map.